share the screen. Is it possible for me to be able to share the screen?
It's possible on Discord.
Okay, now I'm the host. Okay, now I can do it. Okay, perfect. All right. So can you guys see, Karthik, can you double check if you can see the screen?
Yep.
All right. So hello, good afternoon, everyone. I learned this is a great initiative, Bay Area Hacks going on. And I believe most importantly, we live in the Bay Area of Silicon Valley, all the high-tech firms. And you guys should leverage the opportunity to actually learn about the latest advancements in technology, lots of great folks around. From my perspective today, I'm going to actually speak about computer vision and deep learning, not meant to be a comprehensive be all and everything. But the idea there is to just give you a glimpse of where the industry is, what is happening, what are the trends, what you can do. And if I may interest you into doing it and venturing into and getting your feet deeper into this domain, what are some of the terminology, technologies, stuff that you might want to acquaint yourself with that you might find useful in the long run? So with that, I've also wanted to give my email address. I'll put up the slides after the meeting. My email address is there. Feel free to reach out to me. If you have any questions, I'll be happy to answer. And again, thanks a lot, the Bay Area Hacks team, for inviting me, and thanks all for joining. So with that, let's dig into what topics we're gonna cover today. So I kind of framed it up as like, first of all, start by asking some relevant questions, like why deep learning? I mean, is it just another buzzword or is there a real relevance? And then why now? So those are kind of the more relevant questions. Then we'll look at some application examples as to how the automotive industry is utilizing deep learning and computer vision. So throughout the presentation, you will see deep learning abbreviated as DL and computer vision abbreviated as CV. So just to be clear. And then some application on the retail side. Similarly, on the industrial market, what is going on in the healthcare applications and such. And the second half of the talk will be more about, let's say, I think some of you, one of you at least, who I hope, or all of you get interested in building some computer vision apps by yourself. What is the typical workflow? What all it takes to get going on that? What tools are available? What frameworks are available? We also have a concept of AI models. What are some of the models' capability are? And then some things around coding wise, what you may want to equip with, some hardware option, and then uh, some pointers and some questions that you guys may have on this topic. So most important question, and I would say that once anybody starts any activity, engagement, embarks on something new, you must, at least I do, I try to ask myself, why am I doing this? So in this case, why computer vision? I mean, why we even care, why it makes sense. So based upon the current state of the market, it's not an overstatement to say that computers actually can arguably augment the human capabilities. I mean, we are living in COVID times, and even afterwards, even when there is a greater need and there is a possibility that a computer can actually observe something, make sense out of it, and then help decide based on it. I think that's a great capability which didn't exist, let's say, around 8 to or maybe 10 years back. It wasn't to the scale that it exists today. So a lot of significant enhancements have happened, wherein the idea here is that you can pretty much replace whatever the human eye does with these computer vision algorithm made possible by deep learning. So that's the whole idea, that you are pretty much taking care of, in a computerized manner, one of the most critical human sense. And then the goal there is, you have the capability, but it better make some business sense as well. So over on the business sense, what you could use it for. So many technologies exist, many great technologies exist, but apparently haven't found the marketplace, haven't found the business needs. Not in this case. In this case, interestingly, you can do a lot, a big variety of very, very interesting stuff with computer vision. And it ranges from very, very simple things to very complex thing. On the simple task, one thing you could probably do is like count how many people are there, how many objects are there, and such. So those are more observational. You just look at it and make a assessment of the situation. But then there are some really, really very challenging, complex, low latency, as in, if you don't make the decisions fast enough based upon what you observe, like driving a car, the risks are pretty high. So that would probably be the, or I could argue, one of the gold standards of computer vision, wherein, in a way, uh, like when we delegate the responsibility for driving the car to the computer, we are kind of putting our life in the hands and putting faith in the technology. So that does pose some greater risk, but the technology gives us some risk mitigation, some assurance that things will probably be worked out and eventually it should work fine. So that's the hope and expectation from computer vision. Whether it materializes, pans out as we expect, we'll learn in few years. And then the question of why only now, why it's making even greater sense. So I would say now is for the past 5 6 years, it has been the turning point in the computer vision technology. Why? So this graph kind of attempts to answer that question, that when you have, so traditionally before, let's say 2012 13, the challenge was there. I think many times there weren't sufficient computer algorithms to handle this problem of doing whatever the human, interpreting whatever the human eye interprets. But you can see in the curve here, for a simple task like an image recognition, like looking at a picture and saying that whether it's a dog or a cat, a few years back it was supremely difficult. uh, Based upon the significant progress that has been made in the deep learning domain, actually, that you can see towards the right end of the graph, where we are pretty much now. And you can see that computerized deep learning based approaches sometimes even get actually close to human capabilities, and often beat them by a slight margin as well. And this data has like basically proven in many different forums. ImageNet, there is an annual conference, annual competition goes on. Kaggle runs many competition, and most of the winners actually on these forums, especially for computer vision task, actually come from deep learning domain. And how has that been made possible? That precisely has been made possible. Now we have much more computational power. We have faster algorithm to train and infer. And I'll talk about what those terms train and infer mean in this domain. Some of you might be aware, but we can revise that. And then more data capability. Now the ability to have actually lot of imaging video data available for computers, having the ability to observe lots and lots of different contexts, that kind of builds their capability. Because in the end, think of it like a human child needs years of experience and ability to process lots of data to get acquainted with the world. Same idea here. You need a lot of training data. So hoping that I, to some extent, answered why now and why even bother doing it, I'll try to dive into some of the application, how the industry is utilizing computer vision, deep learning. Uh, the first, I think, space or industry vertical, I would say, I picked was automotive. So over here, uh, you might be aware, you must have read news, Tesla has some options, but if you read on Google or news, the current state of the art does show us a promise that cars will be able to work in conjunction with computer vision technology as well as some other sensors. And there will be a level of autonomy in car driving experience that will eventually be achieved. And that basically does utilize some advanced algorithm for object detection, classification, localization. And another aspect is path planning, wherein you try to navigate. The car needs to determine which path it should take. Yes, you can see that, like in this picture, let's say the car can actually see that, yeah, there are pedestrians, there are cars on the right and left, and there are some traffic signs. The big question is that which path to take, should stop or go, what speed to maintain. So that's in itself is fairly complicated task. And there is some significant amount of risk involved there as well. But eventually, the technology and the industry is working to realize this vision. And then there are some simpler tasks, uh, less complex, less latency requirements and such, like prime robots delivering stuff at your home. But here is a picture of what the automotive industry likes to portray, wherein there are multiple levels of autonomy in self-driving cars. Level 5, you will have full autonomy. The car can all manage by itself. Level 4, very in most cases can work without a human help. Level 3, uh, driver may take eyes off, but still I think may have to interrupt in certain situation. Level 2, the car can do pretty much go fast or slow based upon some supervision from the driver. And then level 1 is pretty much what most of the previous generations car had: automatic braking system, the cruise control and such. uh, I believe some of you, or actually I believe most of you, are in high school or middle school. I'm not too sure. A lot of you have got their driving licenses, but yet, but I think it's once you do, or if you have already acquired one, you might appreciate the sheer complexity of the task that is involved in driving a car, wherein you use pretty much all the human senses at once, and you got to be precise, accurate, and making right decisions. Otherwise the consequences for sometimes wrong decisions could be pretty risky. So that's where I think these levels of safety and autonomy have been defined by the automotive industry. So that's one domain to look into. And then the other aspect is other industry to look at is the retail industry. So in the retail, what are some of the ways the computer vision is helping out? I would say there are multiple domains, but most of the current deployments, or where companies are actually utilizing computer vision in the retail market space, relate to these kind of applications. For example, you could enhance the shopper experience. You can see how many shoppers are there in your store at the moment. Sometimes you have limits on how many you want, so that's a people counting application. And then sometimes you may want to see, at least in corona times, you want to see the 6 feet or 8 feet, whatever social distancing requirements are in force, they are in place or not. And then the second bullet on the shopper experience aspect is the engagement side of the things. This is more, you want to see that, let's say this gentleman is looking at this product, and for the Walmart, for the Costco, or for some of the retail players, it might be useful that to figure out how much time you spent on looking at a product, what features you looked at it. So those kind of information is useful for these big manufacturer for the retailers as well as the manufacturers of those products. So there is a very useful data in there, because when people actually buy, I think how much time they spend to analyze a product, that kind of indicates their interest level, as you can imagine. And that information is very useful for uh, in terms of where you want to place your product, what all you want to write, whether it appeals to have enough customers been taking notice and all. And sometimes you might see shoppers doing apples to apple comparison as well. So that kind of information does help. And then in the bottom left picture, actually you can also have, actually bottom right, you can also have the shopping concierge robot who can actually, if you ask them a question, they can actually take you around, tell you which aisle to go to. Again, this is not full computer vision is doing most of the tasks, but actually you are utilizing computer vision as a key technology in these concierge robots inside helping you inside the shopping experience. So this is the top left one is a full, I would say the maximum usage of computer vision. In some cases, it could be a key part of other enabling technology. So bundled together with other technology. And then there is another aspect of retail experience, the point of sale. So if you search on Google, many companies actually, in Asia in particular, they are utilizing automatic checkout. We already have that in US in many places, in wherein you can scan your barcode, but that is like pointing your barcode to the barcode reader. But actually, it could be even better, like in the top right picture, wherein the camera actually gets a video stream or takes a snap of all the product, and then it knows that those are Pepsi cans, those are Twix bars and such, and immediately can count how many of those are there, and then create estimated actually pricing for all those items put together. And it could have the itemized receipt ready for you. All you have to do is that lay them all on a single floor. I mean, many times you get confusion with this such technology if you stack them up and if the camera can't see them. But as long as the camera can see them, I think you can train such models to figure these what these products are, and then assign suitable value to them, and then create a receipt for you. And then the third aspect I wanted to talk, which is very useful actually for the retailers, wherein they want to see the shelf stocking situation, whether the pricing is right, the placement, the products are placed correctly. You don't want misplaced products. Sometimes instead of the guys who are stocking the aisles, the error is actually made. The error is induced by customers actually putting wrong products in a particular shelf. So that is one situation. And then you can also have computer vision technology take care of out of stock alerts. It can immediately scan a panoramic view of the shelf and actually can determine, oh, if this shelf looks empty, that's an out of stock alert. And for retailers, it matters big time, because if they don't have a product in stock and the customer wants it, that's a lost sale anyways. That's a big one. So traditionally, a human guy checking out the stocking level would check it all out, but arguably that could all be done by computer vision and AI as well. So those are some of the application examples in the retail phase. And then if we look at the smart cities, by smart city, I mean actually the overall our transport mechanism, public infrastructure mechanism and such. So it has usage in the smart city environment as well. Like for transportation, you could do vehicle counting. You can estimate the traffic flow, how many cars are moving or flowing in one direction. Arguably, that could have been done in the past with typical RF sensor as well. But now you have a much better handle on what kind of cars are going on. And sometimes actually, you can do other interesting applications which you might have already been deployed in many places. Is the occupancy levels of parking lots. So like in this picture, You can see the camera actually making a determination how many parking spots are available, and then at the entrance you can display how many available. So that could also already being done by computer vision, and it could be arguably further augmented as well. And then, as I said, on freeways, so this is a traffic light camera for the city driving monitoring, and then you could do the same things in freeways, checking out the vehicular flow and such. So a lot of interesting applications exist in the smart cities. And a particular extension of that is in the public transport domain as well. I mean, for the metro lines, the BARTs of Bay Area, you can check out the situation, how many people are there, the occupancy level, and such, and how much distance they are maintaining from the entrance, exit, and those kind of things are useful data many times. You wanna see and make an assessment based upon that. So that's another application area where some of that is already happening. And then some aspect that you may be less have a good feel for it, but equally important is the industrial and the manufacturing area, the things that go in the big factories, warehouses, and such. Um, so that there is a big business out there, there is a big opportunity there, and over there also the computer vision can be of great use, wherein the camera monitors and based upon that interpretation of the scene, you can pretty much deploy it for predictive maintenance. You can see deploy it for floor monitoring as to how many employees are working on the floor. And then you can use it as in the top right for assembly operation. And then you can also do it for quality control as to see that you are having a consistent quality. You want apple roughly same size, these ketchups and sauces filled approximately same size. I mean, those have been mechanically controlled, but you could technically pass them through a conveyor belt and have the camera look at it from many perspective. If the labeling is right, the quantity is right, and everything looks in good shape. So camera can do the job of the human eye in the manufacturing and industrial space. Another big area, especially in current troubled times, in healthcare, significant usage of healthcare. Healthcare can use computer vision and deep learning significantly. I know myself in my family, I think the robots can do the surgery, and it's not just the computer vision does the whole thing, but it's a big piece of doing that surgery and interpreting the scene and making judgment based upon that. So robotic surgery is one application that uses a bunch of image analysis, capturing, and basically the computer vision. And similarly, a new concept, not new, telehealth, but gaining more currency now is the concept of telehealth, where you can send your picture or do a video call with your doctor and he can look at your symptoms. You could argue that just the video call may be enough, but oftentimes you may need to do some special analysis, like you may want to do image crop or do some other pattern matching. Computer vision can do all that actually much faster, much easier, and arguably people even with lesser qualifications should be able to take a look. I mean, as long as they are trained enough in the field to make a judgment call on those situations. And then there are some diagnostic checks, like somebody taking your temperature and blood pressure. Those things, again, the robot could do by itself. And some application which require just looking at things and making a judgment, like detecting skin cancer. I know many companies, many deployments have used detection of skin cancer and other diseases just based upon visual analysis. So that's where computer can indeed and definitely help, provided it has been trained enough with all the right data, it's fairly accurate and such. So those were 4 or 5 main application domains that I picked where computer vision and deep learning is being actively utilized, gaining ground and actually being pretty successful. Not to say that there are not, there are definitely many other domains. There are public monitoring, surveillance, home surveillance, and I think many different safety surveillance related applications exist. So those are a few that I picked, which particularly caught my attention. And by the way, these three or four examples that I pointed, they are not be all everything. I mean, you can find out there is so much going on in the field that it's just a small snapshot of all what is happening. With that, I delve into the next half of my talk is about, let's say, I think you want to get acquainted on like building some computer vision application, like just some technology deep dive, what is available, what you need to do, those kind of things. So towards that, I think it's good to know how deep learning actually works. So I don't know why my scroll is going on by itself. But yeah, so here is how it pretty much works. There are two main phases, training and inference, same like tip other structured data science, but here in you will use, let's say, a bunch of pictures or videos or lots of labeled data like human, bicycle, strawberry. You will feed that data, and then you will have a deep neural network which will initialize to some random weight, but you keep feeding that data and provided the answer that this picture is of strawberry, to make it very simple. It keep reinforcing that behavior that it should identify an apple as an apple and orange as an orange. If you do that long enough and utilizing the feedback path, leveraging an algorithm called backward propagation algorithm, if you do all that and train, eventually you can get a low enough error rate, wherein out of a million picture, let's say if you make only few hundred mistakes, probably that's good enough. I mean, depending on your accuracy level targets. So that's what is most critical, that you train it, you check for error, and keep providing feedback. So that's how this whole training exercise works. But once you are done with that, let's say the top model in the model in the top portion in the training side, then what you know is the weights for those models. So those are the numbers that actually tell how much to amplify or diminish a particular attribute or a feature. In mathematical sense, a number that tells you that what is more important. And then you have generally for deep learning many layers of such neurons. So that's how they typically are architected. And once you do this training comprehensively, you are happy with the error rate, you go to the inferencing stage, and then you deploy that model, and then you just do a forward pass. There is no backward pass. You, let's say, feed a picture of a bicycle without knowing it's a bicycle, and ideally, if your system has been well trained, if the network is well trained, should get the correct answer, that's a bicycle. So the general idea in neural networks is that, generally speaking, and not always, but generally speaking, larger neural network tend to get you higher accuracy, and the smaller ones tend to saturate at lower accuracy. And you need a lot and lot of data to improve your accuracy in most cases. So those are the general trends that you should keep in mind. Large networks need much longer to be trained, but they can get you far greater accuracy once you train them with sufficiently large data size. That's how it works. And then once you did that, some of the tools that are available, one tool offered by Intel is called the OpenVINO. It has the full computer vision product lifecycle. You can, I mean, let's say you can do the cloud or some local training, and then you optimize the model, and then you deploy it on a particular hardware of your choice for running the inferences. So there are tool chains like OpenVINO that make enable. So the link is there. You can go to that site. You can basically, it's a software package that basically lets you run lets you run a trained model on multiple hardware platform. So the idea here is that uh, generally speaking, in like when you start from scratch, or you are in the early phases of acquiring computer vision technology, what you would do is that you will take a pre-trained model with some weights doing a very similar task, and then you will provide your own images, and you will try to train that model for your own set of images and your target deliverables, and then you train it for your task. But sometimes you may be just happy with what you have available, and then you can use it as is. In this case, the inference model optimizer is actually optimizing it for hardware, and then you can use it for multiple different platform. An easy one to check is actually your own laptop. For modest computer vision task, actually your own laptop with a CPU, maybe let's say Intel Xeon or any other CPU, in many cases could do the job. Sometimes you want to use a GPU, you want to use a FPGA, or sometimes you may want to use a particular hardware called a hardware accelerator. uh, like some examples are Intel's Movidius line of hardware accelerator, which are called the vision processing unit. So CPU, GPU, VPU, vision processing unit, and FPGA is a field programmable gate array. I would say the bottom three options are something that you would need once you have gained enough acquaintance of computer vision for initial trials or doing everything on the cloud or the application side. I think CPU many times does the job correct. And if you go to any cloud provider, uh, let's say AWS, Azure, or Google, many times actually they give you reasonably good enough. I mean, I won't say the very powerful, but decent CPU and GPU options so that you can create an instance in the cloud and try things on your own. But for computer vision, actually, I will try to wrap it up in the next 10 minutes because I want, actually, next 6 minutes, because I want at least 10 to 14 minutes for some questions. So there is a concept of frameworks, which basically are a higher layer of programming abstraction. But basic idea is that instead of writing everything in C++ or Python, you have pre-built libraries that you can leverage, and they make it easier for you to write code, especially for computer vision. So there are many of them. This is like a alphabetic soup of all the technologies that exist. NLTK for natural language speech processing, Theano, NumPy, Spark. I would say that these TensorFlow and PyTorch tend to be fairly important based upon the data you will investigate on the internet. And you may have an opinion, but here is what I found, that for I think, let's say look at the research paper recently, TensorFlow and PyTorch pretty much have the highest adoption rate. I would say that although in the industry TensorFlow tends to be more common, the researchers probably somehow like PyTorch more. That's my personal opinion. But both of these platforms are good. Both of these frameworks are pretty good if you want to get going on computer vision, actually. So good tools. All of them have their advantages and disadvantages sometimes, but I would say in terms of popularity, these two are getting quite popular. And then some sample classes of what I meant by models. So there are many pre-existing models for doing different kind of things. And we call them by the task that they do. For example, the semantic segmentation means like you identify zones where there is a grass on the ground, a cat walking on the ground, and there is a tree in the background, and then there is a blue sky above. So then you mark the zone. And then you can also figure out there is a cat in the picture and try to put a what we call a rectangular box called, in the CV jargon, it's called the bounding box, drawn around the cat. You could also do object detection. In this case, two dogs and two cats are detected and a bounding box is drawn around them. And another recent interest has been to do instance segmentation, which basically means that you exactly mark in each of these pixels of this photo which one belongs to a dog, which one belongs to a cat, and such. And then you also do the instance separation. Like there is a one dog marked in red color and one dog marked in green color. So that is like a pixel level analysis, pixel level segmentation, and that's why it's called instance segmentation. So these are some four main models on the classification and detection approaches. And then you can do many other interesting things like human pose estimation. You can make a wireframe body model. Some models actually can recognize the text that exists. So there is a text recognition models that exist. And then there are some text spotting wherein they draw not a rectangular bounding box, but more of a curve, and then put the actual text on top, overlay that actual text on top of it. So those are some samples of the deep learning computer vision models that exist. And some tools of the trade, if you want to get going, there are many, I think, tools available and frameworks available, but I would say programming languages wise, C++ and Python both run in hand to hand in terms of uh, what you can do with those frameworks. If you know one of those or both of them, I think it could be pretty useful and handy to catch up faster on the existing state of the art in the deep learning and computer vision. Because in the end, you will realize that actually many times in deep learning and computer vision, you're not writing things from scratch, but you're actually leveraging a lot of work that has already been done. So to that becomes a point of taking something that already exists and adding your own contribution on top of it. So that's where I would say argue that these programming languages have a good place. Hardware wise, as I said earlier, you could do it on CPUs, you can do it on hardware accelerators. Intel makes something called Movidius line of chipsets. One example product that they go in is called NCS Neural Compute Stick 2, available on Amazon as well. You can just stick it into your laptop and do some uh, AI computer vision work. Uh, or arguably your laptop itself could also do it, but let's say you want to offload it to compute stick, that's another option. There are some tools available. You could do it with Raspberry Pi with NCS2 stick as well. So those options are there. And then for real, like the deeper work in the industry, you can use GPUs or even field programmable gate array. So multiple different product options are available depending on your expertise level, task complexity demands, and such. So that's where there are many different hardware platforms available to do the same task. Some will run faster, some slower, some cheaper, some very expensive. So those are the kind of trade-offs that you need to make. Uh, Last slide, I promise, before I shut up. And I think would think it's a great opportunity for you to guys to ask some question. Some events, I think, where you can learn some industry folks talking about it. So Google and TensorFlow actually sponsor a TensorFlow World Summit every year. I think there is one coming in up in September. If you are more in the research focus, IEEE has this conference CVPR that just passed. I think that is like if you want to get really knee deep into the algorithm and the like the core work on the computer vision side. And then generally, I think acquainting yourself with some of the events from the cloud providers. For example, Microsoft and AWS both have some marquee events like Ignite and reInvent. And the idea there is that they have covered a lot of topics, but you can pick which ones you want to listen to. I don't know for sure, but I think ever since COVID-19 has happened, some of these events are actually available for viewing online. And anyways, the content that is shared is available online after on YouTube anyways. But even otherwise, I would imagine some good options are available for registering and watching these on webinar mode if you are interested. I think because of Corona, many of the things are happening in online only mode. So something to take a look at it. And then forum wise, Facebook has AI and DL forums. Many forums exist. The tool that you use, discussion boards, OpenVino, Open Computer Vision, those tools may have their own forums. Those are all good places to check out. And with that, I think 12 minutes before our 2 p.m. mark, I am done. And thank you all for listening. And if you have questions, please feel free to go ahead. I will try to answer.
All right, thank you so much, Mr. Vikas, for your guest for the presentation. So, I guess now we can open it up to questions. So, I see a lot of people that are chatting. So, if you guys have questions, then just speak up. I guess just unmute, or you can just look in the chat box, and then he can answer for you.
I have a question. So, are you still here? Can you hear me?
Yeah, I can hear you well.
So I have a question about open Vino models because I've been doing a project with them, and what I saw is that they only work on the Intel hardware basically. So like you need the Intel CPU or like compute stick or something to run the models, the pre-trained ones. And I kind of wanted like to make it be runnable on other devices. Is there like any way to do that? Is there like maybe any modifications I could do like with the model architecture or the weights so that it could run like on other devices except Intel?
That's a great question. Yes. So the idea there is, I think it has been enabled for Intel devices, but I am aware that some of the other boards I know, for example, Raspberry Pi, at least might be able to work. I may have to check upon that, but I think that's a great question. And let me, since you mentioned, let me quickly check. So for the Raspbian OS, this link exists. So I think your point is well taken that many or actually most of the options available for are for the Intel hardware, and sometimes you may want to try it for different platform. So here is one non-Intel platform that I'm aware, Raspberry Pi 3, where this page it says it should work. If you have questions, I can point you to the right folks who maybe were like making this happen, or there is a forum where you can pose this question and they will actually precisely show you how they should work. But basically, yeah, I think there are some options, but yes, I agree, not many options. So for example, this ARM7 VA CPU architecture is also being supported, and you may need Intel NCS neural compute stick as an addendum to the Raspberry Pi. So those are the non-Intel options I am aware of. But that's a great point, and I think the OpenVino team is aware of that, and they may or may not commit to more hardware in future. But at the moment, yes, your assessment is right that most of the products supported are the Intel products.
All right. Yeah. Thank you.
Any other questions?
Can I go with one more?
Yeah,
So
go ahead.
yeah, basically like your models, as I checked them, they're like the model itself is the regular one. It's like .json, and the weights for the model they're like kind of weird. They're like .bin file or something. And I was wondering, like, is there a way to like upload in like Keras or TensorFlow, like you usually upload the weights, because they're usually like in H5 extension or something like that. And this kind of extension is like it's .bin, and I'm not sure like how to upload the model like into Jupyter Notebook or something. Like, have you ever tried doing that?
So the idea there is actually you take a model out of Keras and actually you try to fine tune it for a specific hardware. So the idea there is actually to, I mean, do the path more towards the hardware away from the pure software. Keras and uh, Keras, PyTorch, and TensorFlow tend to do it all for in the software domain. So this pretty much the model optimizer actually fine tunes for a specific hardware. And you're right, actually, it gets you the output in a XML and binary format. So those XMLs and binary are actually more for a specific model. Uh, so the idea there is actually to you already have the model weights somewhere, and actually you are converting them to XML and bin format. So in my understanding, you should have the model weights before plugging it into OpenVINO. Is that correct assessment?
Yeah, like basically I just like have the models from the like OpenVINO or whatever, like the hub where you download your models. And as I understand, the weights are in that binary file. So I
Mhm.
was like, I'm not sure if Keras or like TensorFlow, they support like uploading that binary file weights. That's what I was asking. Like, is it like any way to convert them to like them
So
like more appropriate format?
So short answer to your question, to the extent I am aware, the answer is no, in my opinion. But I mean, again, I think you may want to pose it on forum, but in my
Yeah,
understanding, you
yeah.
cannot backport those numbers into TensorFlow backwards. It's supposed to be take in the TensorFlow model and get into the OpenVINO IR format, the intermediate representation format.
Okay. Yeah. Thank you. Thank you.
Yeah.
I had a question.
Mhm.
So for for the fine tuning of the hardware, like once you get the deep learning thing from either the from one of those services that you mentioned, forgot the names of it, but one of them used C++ and one of them used Python. But so once you get that and then you fine tune it, like how would you like are they like today are they using cloud computing within it, or like some kind of like semi variant of it with it, instead of just fine tuning it to the hardware, or like or are they doing something like let's say like if the deep learning thing detects if like the response will be the same, then it's not going to pull from the cloud, it will just pull from memory.
Yeah, so I think most of the talk I talked about like more of a local implementation, but there are some cloud native implementation as well. So for example, Onyx runtime and OpenVINO have been integrated. So basically their idea is that you have a cloud-based model and then you deploy all the way from cloud to edge. I believe you can actually search on, for example, Onyx is the Azure's one runtime that they provide, and there the idea is that the whole pipeline of you actually you will do the training, you will do everything on the cloud, and you can actually do the inferencing as long as you have the images and everything in the cloud. But if you want to do something what they call the edge towards the device end of the thing, cloud can actually push those models to your edge device, and you could do the inferencing from the edge. And actually Azure has many pieces in between, Azure IoT Edge and all. And if you integrate all that, there are some ready to use recipes well integrated with cloud side of the things as well. Depending on where you want to do everything on the cloud, or you want an integration of cloud and edge, or you want to do it all local on the edge. So there are options for all three configurations. And in the Azure case, I can suggest actually this Onyx runtime and OpenVINO integration. There is an OpenVINO available integrated, so you can actually. I may have to look up the particular page, but I can actually point you to the web cloud that actually tells that shows you how to go about doing that. So that solution is fully integrated with integrates the edge to the cloud. Does that answer your question, or you had that in mind, or did that answer question? Or?
Yeah. My question was mainly around like cloud computing and like, like because uh like throughout the years, like the processing power, or I know one of the goals of it is to just try to like make it as efficient as possible without using or with by using the lowest amount of processing power.
Mhm.
So like I was asking kind of like two things, like one was, are they using cloud computing in it, and if so, how? And then the other one was like, are they using any shortcuts like I mentioned? So yeah, pretty
So
much answered
cloud,
it.
yeah. So cloud is used for training and deployment, wherein you train and get your model ready, and then you can push it to the OpenVINO runtime actually from the cloud. So that solution, I am aware, is available for at least for the like the runtime on the Azure side, which is their Onyx runtime. So here is a code base that actually I myself had a certain involvement with. It's all in public domain. So
Uh,
there
uh,
are actually,
okay. So I was using Google Cloud earlier this year,
okay.
and then I switched to Firebase. So like,
Mhm.
does Firebase work as well?
So Google Cloud wise, I at the moment I am not aware of any integration, but there is a team in Intel that works more closely with the cloud providers. If you can send me the query, I can forward that query to them. But basically, as much as I am aware, I don't think such an full integration on the Google Cloud exists. On the Azure, I am aware, and similarly on the AWS Green Grass as well.
Okay.
Any other questions?
Yeah, I actually had a question. Can you hear me?
Yes, I can.
Okay, cool. Thank you. So pretty much like this is more like a broad question, but I know you talked about self-driving cars in your presentation, and I'm just wondering, like it seems that I know Intel with OpenVINO, they're focusing more towards edge computing, which is happening like locally versus cloud computing is like communicating. So I was wondering, what do you personally think in the future self-driving cars will be more geared towards? Do you think it'll happen all on edge on the car, or with the advent of 5G and all these like quicker, faster, efficient communication, do you think cloud-based, I guess, inference for self-driving cars would be the future?
Yeah. So again, I will put a disclaimer first. This is my personal opinion, nothing for the Intel or anybody else's. My personal opinion is that you could have all the 5G cloud connectivity, but a significant amount of processing work needs to happen on the car itself. So the cars will be far more capable than you would imagine and be in a position to make decisions by themselves rather than getting some instructions to do something else from the cloud over the 5G or whichever V2X network or V2C network, vehicle to cloud network they end up choosing. So that there's some communication and control may happen, but I would argue a lot of heavy lifting will happen on the car itself. That's my personal opinion.
For sure. Thank you.
All right, we are 2 minutes over the hour. If there are no questions, let's wrap it up. And Karthik and Siddharth, thank you for organizing this. And folks, any of you, if you have further questions, please send it over to me. I can route it, or if you want, you can directly go to OpenVINO forum or any of these cloud providers forums. That's many times those companies are fairly responsive, which I believe they should be. So feel free to reach out to them. If I can help in any manner, definitely reach out to me. So um, I believe that's we have come to the end of this talk, unless there are something else. Karthik and Siddharth.
Yeah, all right. Thank you so much for being a guest speaker for us today, and we really appreciate like the talk. It seems like there's a lot of interest and a lot of questions. So thank you for this. And so for everyone else, for the raffle, we can do that. We can do that right now.